Let the universal set for this problem be the letters Q, U, E, S, and T. We have 3 subsets listed here, and we're supposed to determine the elements in each of the following subsets. Well, first of all, I'm going to put this on the board here. Let's try my favorite color, purple. There, that looks good. What I don't like about this is that there's nothing outside of this. So really my universal set is tight around all 5 of those elements. All right, so what do we ask for? Determine the elements in the following subsets, including the proper set notation. We want A union B, A intersect B, and we want D complement. You've seen the answers here, but we're going to get an explanation in just a moment. And then the complement of A intersect B, what we find in part C. As well as the union of the complement of the individual parts, A and B. And I think that's it. Let's see what's going on. All right. Let's get this zoomed in a little bit. All right. So union is a fancy way of saying or. Well, we have to be careful about how we use the word or in mathematics versus how we use the word or in everyday language. Usually we hear of 2 options, pick one or the other, but not both. In mathematics, unless they specifically tell you, when you hear union or, it is talking about an inclusive or. In this case, that means lump everything from A and B together. So the union of A and B, you're getting S, T, and E, as well as Q. Even though S and T are in the intersection of A and B, we include it. It's an inclusive or. We'll put that in alphabetical order here. E, Q, S, and T. I already mentioned that we have the intersection, what's in common, i.e. what's in both A and B, that is the S and T. Notice how I'm putting the curlicue braces around all of that. D complement. Complement of a subset would be everything that's in the sample space, which is not in the subset that you started with. You could think of this as related to subtraction. Take away Q, U, and E that we had in D. You're left with S and T. Furthermore, the reason for the name quite likely is if you were to take the subset D and what we just got for D complement, they have nothing in common. And when you union them together, you get the complete sample space. So complement, completing the sample space. Now, as for A intersect B, finding the complement of that, then since A intersect B was the elements S and T, the complement of that is going to be everything else besides those 2. So we would have the E, Q, and U. As for the last part, first I'm going to find out what a complement is. A complement had, A itself had S, T, and E, so its complement has the Q and U, everything else in the sample space besides the S, T, and E. We want to union that with the complement of B. B had S, T, and Q. So everything else besides S, T, and Q, that's the E and the U. So when we take the union, remember we're saying it's in this or in this, but it's an inclusive or. We just lump all this together. Notice also, by the way, that when you list a set, not only do we not care about order, so I'm just keeping track of things here by putting in alphabetical order, but that is not necessary. I could have put Q, U, E with commas in between, and then the curly Q braces around that. That would still represent that. The other thing is, I don't list the U twice. Once it's in there, it's in there. List it once. See what else we have. We can double check the answers here. Okay, the work I had before matches up. Okay.